Hello there, ladies and gentlemen. For this quick little video lesson, we will be discussing how to find certain angles in given quadrants if we know their trig function value. So this is what's referred to as circular functions. We're going to try to find an angle on a circle, basically on a graph, as long as we know what ratio the sine, cosine, or tangent gives us. So there are a couple things that I want you guys to kind of keep in mind. First off, we're going to make sure that anytime we do these, we're paying attention to the quadrant. Always keep in mind what quadrant this thing is in, whatever your angle is, because that's going to affect the difference between maybe 150 versus 210, or that'll be the difference between 60 versus 300 degrees. As long as we know the quadrant, we'll have a more accurate angle measure. The other thing I want you guys to keep in mind is that when we use our calculators, and I'll write this off to the side, when we use our calculators, we will disregard the negatives. So disregard the negative sign when you punch this into your calculator. So that way we're always getting a reference angle that is less than 90. All right, so without further ado, let's go ahead and get the first one going. So I have the sine of some angle is negative 0.309, and theta is in quadrant 4. Well, if it's in quadrant 4, I know it's going to be down there. So that means my angle, if I were to have started from the origin and worked my way all the way around, it's at least 270, but it's less than 300 degrees. So what I'm going to do is I'm going to figure out what is this little reference angle. What is that little theta right in there that gives me the value of 0.309? So I need to use some inverse trig here. So sine with a little -1. And right here, I'm going to disregard the negative, 0.309. Once I have that written out, let's go over to our calculator. Make sure we're in degrees. And we're going to calculate inverse sine, so second and then sine, 0.309. That's going to give me a value of 17.9. You know what? Let's just call that 18. So we have a value of 18. Our theta value is 18 degrees. Well, that's really just a reference angle. That tells me how far from the x-axis it is. So if I'm 18 degrees away from the x-axis, that means my real angle, if I were to take this thing and go all the way around and stop just 18 degrees shy, well, that would be 360 minus 18, and that's going to give me 342. So my real answer here is going to be 342 degrees. Now the reason why I say to disregard the negative signs is because that sign value will show up at two different spots on our triangle or on our graph. So if I redid this and I included that negative sign, so instead we have negative 0.309, you'll notice it's going to give me negative 18 degrees, which, yes, is true. We did go down 18 degrees from the axis, as it shows right here. However, for all we know, that could have also taken place in quadrant 3. So we have to make sure that we're being very, very careful with this. All right, let's do the second one. Cosine of theta equals negative 0.7660. It's in quadrant 3. So let's sketch this out. Quadrant 3 is going to be down there. So it's going to be bigger than 180, but smaller than 270 for my final answer. I'll have to do some inverse trig to get my theta value. And again, we're disregarding that negative sign. So this theta is our reference angle between the x-axis and our terminal side. If I head over to my calculator, inverse cosine of 0.766, remember I'm disregarding that negative sign for now, is 40 points, we'll call it 40 degrees. So over here we have a 40-degree theta. Well, that's 40 degrees past 180. So if I went 40 degrees past 180, if I add those together, 180 degrees plus 40 degrees, that's going to give me 220 degrees. That is the angle for which cosine would equal negative 0.7660 with my theta in quadrant 3. And if I really, really wanted to, I could always double check this by doing cosine of 220, making sure that I have 7 degrees, good. And bam, negative 0.7660. All right, last one is somewhat of a doozy, but not terribly bad. We have the secant. Well, secant pairs up with cosine, remember. We have secant of some angle theta equals negative 3.1459 and is in quadrant 2. So let's sketch that out. Quadrant 2, bam. It's going to be at least 90, but smaller than 180. This is the reference angle right here that we're looking for. Well, I don't have a secant button, however, I do have a cosine button. So I'm going to rearrange this so that it's cosine friendly. Hopefully we remember that secant and cosines, those are what's called reciprocal functions. So I'm going to rewrite this as 1 over negative 3.1459. Now from here I get to use some inverse trig. So cosine inverse of 1 over negative 3.1459 is going to give me my theta value. At this point, all the hard stuff is done, so I just have to go over to my calculator. We're doing the inverse cosine of 1 divided by, and remember, when I punch this in, I'm going to disregard that negative sign. So 3.1459. Again, I am disregarding that negative sign. That's going to give me 71.46. Let's call that 71.5 degrees. So theta is 71.5 degrees. Well, if I wanted to find the angle measure, if I started in standard position and worked my way around, that's going to be 180, so the x-axis, minus 71.5, because I just barely fell short. So we can calculate that real fast. 180 minus 71.5. And boom, 100.5 is our answer. So 100.5 is the angle that if we plugged into a secant function would give us negative 3.1459. And that's it, and that's all, ladies and gentlemen.